Hey everyone, welcome back to AWS On Air. We are live here in New York City at the 2023 AWS New York Summit. My name is Jeff Mershak, and I'm a solutions architect on our Department of Defense Air Force team, and I'm joined by my co-host, Jillian. Jillian, say hello.
Thanks so much. So my name is Jillian Ford, and I'm a startup solutions architect. And we've got Andy.
Andy, introduce yourself.
Hi there, I'm Andy Schutz. I'm a principal product manager with the AWS HealthImaging service.
Health imaging. Now, you had an important announcement recently.
Yes.
What was that?
HealthImaging just went generally available, so it's now available globally, and it is HIPAA eligible, which means it's ready to store protected health information or patient data.
All right, so we're going to get into how the service works, but let me just say, I've been to the doctor a bunch lately, and I could tell the medical assistants, the office workers, they're all stressed out, and so they're stressed out. There's a lot of note taking to be done. Even the doctors have to take a lot of notes, and in fact, it seems like a lot of times their assistants are kind of transcribing a lot of those notes.
Yep.
And it's just a lot of work. So it sounds like this new service that was announced is going to help that in some way.
Yes, that is our goal. So we see strong growth in medical imaging. There's more and more medical imaging studies being performed as patients need care. Physicians have to understand what's happening inside of a patient's body.
So is that the fancy way of saying X-rays, or is it
X-rays,
or is there
CTs,
more?
Good question.
MRIs, and I'll show you a couple in a couple minutes.
Awesome.
Oh, cool.
Yeah.
Yeah, so the number of studies is going up, but the number of physicians or radiologists or nurses is not growing as fast. So you're seeing real strain on the healthcare system. And so what we've built here is a purpose-built service that stores medical imaging data, specifically in the DICOM format, that kind of takes away some of the complexity that health systems are dealing with and makes it easier for independent software vendors, ISVs, to build applications that simplify those clinical workflows you've observed.
Well, it's interesting. I'm glad you brought up X-rays, CT, all those. It seems like there's a CT machine company that developed the software that runs that machine. There's probably a machine hooked up to it, and that picture gets taken. It's stored on that hard drive. But the X-ray machine's probably made by another company.
Yes.
might be on a different operating system that only certain people know how to use. It gets a picture taken and saved on that hard drive. And now we have to have a doctor go to two different rooms maybe to look at different files.
Absolutely.
Wow.
Now, I'm painting the picture for why cloud computing could help that, but it sounds like health imaging is going to help that as well.
Exactly. So one thing that we do is by putting the image in the cloud, we can have a single authoritative image, and that means you don't copy it multiple times.
Yes.
Storing copies costs money, so we can eliminate or we can decrease cost of ownership about 40% from medical imaging data, just by getting rid of extra copies and simplifying infrastructure.
And that's HIPAA data, so you don't want to have 20 versions of HIPAA data out there if you only need one, because that's more attack vectors for someone.
And you don't want to be looking at an old copy.
That's true, yeah. Absolutely, yeah.
So the other thing that moving the data to the cloud enables is, more intelligent workflows. So now we can use algorithms. We can collaborate. You talked about care teams. How do people come together and care for a patient? And how can we unlock new research possibilities?
Yeah, well,
I like that.
Yeah, and I know that now we're seeing doctors from different parts of the country coming together for a virtual meeting and all talking about one set of CT scans and say, what do you think? What do you think? This person's in Seattle, this person's in New York. So that collaboration is a big thing as well.
Absolutely. And the pandemic, put a lot of stress on the health system. But one thing it did is it changed where people work and how people work.
Yeah.
So one of the benefits of the modern way people are delivering care is the team might be outside the walls of the hospital. So the radiologist might be from a contracted organization, not actually part of the hospital system. Or they might be working from home. And what that can mean to patients is they get care sooner. They get the results of their exam quicker than they might have in the old model.
That's really good. So it's obvious, really, what the benefits are for the actual healthcare practitioners. But what about for the builders, really, at home who are watching?
Okay, well, great. That's actually who we're targeting. So traditionally, organizations that built applications for medical imaging had to do a lot of hard, low-level infrastructure provisioning. This is, fairly large amounts of data.
Yeah.
And they had to do a lot of basic business logic as they're ingesting data. We currently ingest data in the DICOM format. So it's a specific healthcare data format that's metadata and pixel data. They're recompressing that data. We take all that on with health imaging. And that allows ISVs and solutions integrators to actually focus more on the application layer.
Nice.
Bring more value to their end customers.
Really cool.
Yeah, so does that mean, let's take a CT machine, for example. How would AWS Health Imaging work with, say, you're a CT machine manufacturer and you want to not worry about all that stuff and use health imaging? Where would it plug in?
Well, maybe I could walk you through it.
Oh, I'd love to see it.
Okay,
Yeah.
cool.
That'd be great.
So I'll show you a little demo.
How about that transition?
Yes, I know. That was perfect.
Okay, so is my screen visible? Yep. All right. So as of today, AWS Health Imaging is available in the console from the CLI, and there's SDKs. So this is from the AWS console, and you can see the service. So before I dive in, I'm actually going to show you this kind of end-to-end diagram that shows that life cycle. You mentioned the CT study.
Yep.
So maybe you've experienced this, but these big machines, we call them imaging modalities, they scan patients. That's like X-rays of your chest, MRI of your knee. CT scans is kind of like a modern X-ray. It's used for everything. That generates medical imaging data. That's often stored on premises in something like a vendor-neutral archive.
Yeah.
Or the PACS application, which is what a radiologist looks at.
Well, that's probably something that we've all had experience with, changing doctors, and then your new doctor wants, you have to go to your old doctor and sign something or bring your X-rays over. Yeah, that could be a big headache, and I can see this helping out with that.
Yeah, because what we're going to do now is move that data to the cloud and make it easier to share. So the way we do that is we stage the data on S3, and from there we trigger asynchronous import jobs, which will import DICOM data either one image at a time, one study at a time, or even 30 gigabytes at a time if we're doing a bulk migration. And you can run lots of those jobs at one time, so that's how you scale up. And as the data is ingested, it's going to be automatically organized by the service into what we call image sets. Wow. And those are collections of images with consistent metadata down to the series level. And we're also going to compress every image in a state-of-the-art codec called high-throughput JPEG 2000. And that codec is optimized for retrieving it over the web so that we can have low-latency retrieval for these clinical applications at the right. So getting that image in front of a radiologist fast, or enabling collaborations for research, or building, training, deploying ML models integrated with SageMaker and other frameworks.
You were saying earlier about how it automatically organizes the data and in a certain way. So do customers, can they choose an option?
Well, we do it with health imaging. We do it with consistent metadata, image sets. But then after it's ingested, there's APIs to change that.
Oh, cool.
If you want to combine image sets, partition image sets. So, we call ourselves workflow agnostic. There's a lot of ways you can manage this data. And we're not opinionated about that. We just give you the tools to manage it as you like.
Yeah, well, if the metadata is stout, that's really up to you to do however you want to pull based off the metadata. Yeah, I like it.
Okay, so going back to the console, the way you get started is by creating a data store. And that's, click this button over here. But I've already done that. It takes a couple minutes to make a data store.
All right, so let me interrupt you really quick. Having X-ray images, medical imagery, that's HIPAA data. We talked about it.
Yes.
How does health imaging, is it HIPAA compatible? Is
yes.
it accredited? How does that work for people that need to sit through that HIPAA auditing every year?
This service is built for health information, so it is HIPAA eligible right now.
Wow.
And we have artifacts like AWS Artifact that can help you link the compliance artifacts we provide with your regulatory frameworks.
Awesome. Perfect.
Yeah.
So for anyone who's not aware, you'll probably have to sit through a yearly HIPAA audit.
Yep.
And you'll have to say, for this application, you have to provide evidence about that you're meeting all the HIPAA controls. And basically, I think what Andy was saying is that the portions that you're using AWS Health Imaging, you'll be able to inherit or pass the controls that we have in AWS Artifact and say, look, I'm using this, and I inherit all these controls, and That's less that you have to worry about.
Exactly.
Yep.
It's less that you have to worry about. And it's built with AWS best practices, secure by default.
Yeah. Sorry to interrupt, but I want to talk about
that's
it.
a good
super
call out.
important.
Yeah.
Super important call out. Okay, so here's my data store. You can store one image or you can store petabytes in this data store. It's fully managed. The way we get data into it is with staging the data in S3. So I have two medical images. So they're in the DICOM format, .dcm. And I'm going to trigger an import job. So I'll show you from the terminal.
You'd mentioned earlier there big files, and each one of those were 7 megs. So those are pretty decent big files.
These are X-ray files, so they're fairly good size. And so I actually pre-baked this because it's a lot of typing. But what you can see here is that we're going to call the medical imaging service with the CLI. And we're going to start a DICOM import job.
Yeah, what's interesting, so it started with AWS, and then it looks like it's medical imaging is the call there. And walk through it really quick, even though you have it all typed out.
Okay, cool. So I'm going to identify my data store. I made a little bash variable to make that easier. That's the data store ID. And then I just showed you that S3 bucket. So I'm going to point to that S3 bucket. The next thing is an S3 output bucket. So health imaging is going to log everything that happens during this import job. You know, where did my images go? How they've been imported into the service. And then I'm going to specify an ARN of a role. So because this is a HIPAA eligible service, we're going to be very careful about who can call it. So I'm going to grant access to the service to come into my bucket and get my data.
Perfect.
And then finally, I'm going to specify the region. So I can kick that off, and that will run, about a minute. It's going to tell me that that job is submitted. I'll also...
you just submitted an import job. Now you're trying to list import jobs to see.
Exactly. I can't type and talk very well.
Passing your environment variable.
Yep. So hopefully did I type that right? And so we'll come down here. Yeah. We should see one running here down at the bottom. Unless, it was kind of slow. It's already done. Oh, that's in progress. Yeah. So you can see that job is running. And going back to the console, that job will show up here as 2 image sets because there's actually 2 views of the patient in it.
Okay.
So here is what the organized data looks like in the service. And these kind of groups of common metadata would be one study. So now that the data is in the service, we can call the APIs and get it out again. I mean, that's what physicians and radiologists want to do is they want to use the data for delivering care. I could show you how to use those APIs, but I thought it would be more interesting. Oh, no, I realized I just closed my window. I closed one of the windows I needed for my demo.
Oh, no!
That's all right.
That's kind of the joy of doing it live, right? I mean, it's just things happen.
I think, nope. I blew it.
That's okay.
Yeah.
There it is. I think. Oh, and we're back. Okay.
Oh, cool.
You didn't memorize your CloudFront distribution URL? Come on, man.
It's been a long day. Okay, so this is an example medical imaging application. It's actually open source. It's from the Open Health Imaging Foundation, or OHIF. And this open source viewer is actually integrated with health imaging today. So you can download this from their GitHub. We're going to be publishing an open source sample or solution that will make this super easy to get started with.
Is there like a connector, or you kind of just link to, I forget what the term was in health imaging.
We partnered with the foundation here to make a connector that makes it really easy to extract data and use it in this front end.
Wow.
Okay, cool.
This is what's called a zero footprint viewer. So the only thing that's happening here is data is streaming off of health imaging, and it's being rendered in the web browser. So it's definitely what the modern architectural pattern is. You know, thinner clients, more happening in the web browser. But I have
we see that all the time in the doctor's office. The doctor comes in and logs into a web page. It's not even thick clients anymore. So yeah, absolutely.
That's where the space is going. So I have 2 studies here. So the first one is a chest X-ray, and if I had a particularly fast internet connection, I would have rendered that in less than a second.
Oh.
So about 40% of the studies that a radiologist look at are going to be of this type, a 2-view chest X-ray. And they're only going to spend a minute or 2 looking at this image. So it's important that we can put it up in front of them very fast. And you can see, I can adjust the levels in here and see the tissues of different densities, see more emphasis on the bones versus the structures of the lungs. Look at the patient from the side. So that's just like the very classic vanilla example of a medical image.
So just to summarize, this open source kind of web front end for health imaging is pulling these images from AWS HealthImaging.
Yep.
Good question.
And so to simulate if someone had x-rays taken and a doctor somewhere else or maybe even the same office needs to see those right away, this is how they would do it.
Yep.
Possibly in the room with you.
Yeah.
Discuss you. Okay.
This is live and direct.
Yeah. Okay. Cool. All right.
So now, a little bit more complicated example. This is an MRI, or magnetic resonance imaging, and a little bit more complicated imaging modality.
Because we always see the different layers as it goes through it.
Yes.
Yeah. So that's a lot of pictures, I imagine.
Exactly, and we're going to show it from multiple sides.
Yeah.
So here's an image from the side of the individual's head, and I can actually show you a little bit more complicated view of that.
Whoa, that's cool.
In practice, radiologists are highly specialized, and so they have very particular ways they want to see images.
We always see them throwing up the things up on the, the light, like,
That is, those days are over. It's all digital now.
All right, cool.
So now I've synchronized the views in a couple different directions. And so this view here on the top left is from the side, and the green lines are the planes from the other directions. And I can adjust the levels to kind of see this image better. And as I scan through,
oh, I see.
You can see the other directions. And we can update this real time. So now I can scan through in this other plane from the vertical plane. And all this is happening directly off the service, rendered in the browser, and it's fast.
Gotcha.
This is so cool.
So that's an overview tour of what we launched today, and it is available. Please give it a try.
So I was about to ask, how is this? We just talked about the benefits to the patients, to the doctors, and everything. So how does this service make it easier for the companies that make these machines? Is it that standard you were talking about?
Yeah.
Adhering to the medical image standards? Because I imagine at some point that those companies have to make the decision, we are going to stop developing our own software for this and maybe use the software.
Yeah, I mean, what we want to see is that the companies that are building clinical applications for radiologists, for all these different workflows, they keep building those. But they worry less about block storage, about backups.
HIPAA compliance.
Yeah.
Yes.
We're going to take on that classic AWS undifferentiated heavy lifting. We're going to provision storage, scale up the infrastructure to make sure that all these images are available for immediate retrieval all the time.
Wow.
And then they focus on, these pretty pictures we're seeing here, the application layer.
So, go ahead.
Oh, I was just going to say, because I know we're running out of time, so I'd love to know, where can people go if they want to really learn more and get hands-on?
All right. Please go to AWS.amazon.com HealthImaging is the URL, and you can search for it in the console. There's documentation on our website, so it's ready to go. Generous free tier, so you should be able to kick the tires.
I love that free tier.
Yeah, well, Andy, thanks so much for sharing with us. It was great to see the demo.
Yeah,
thanks for coming out.
So definitely my pleasure.
Yeah. All right, everyone, we are again live here in New York City at the 2023 AWS NYC New York City Summit. We'll be right back after these quick break.